Question number 6, again exercise 6.2 continued. Question number 6, this is the diagram given, a triangle PQR in which AB parallel PQ, AC parallel PR is given, and you are asked to prove that BC also parallel to QR. Now you see two conditions are given. First condition, see, I have already written what is given and what we are asked to prove, already written. Now see the first condition, AB parallel PQ. So from this diagram we will take out the part, okay. For this first condition we have to take out which part you see. It is AB parallel PQ, AB parallel PQ. So we will take out this triangle POQ. So we will mention here in triangle POQ. This is POQ. We'll take out. I'm drawing it here separately again. POQ, in which this AB is given parallel. So BC parallel QR. Therefore, in triangle, this triangle by BPT, basic proportionality theorem. What you can say? You see, OA by AP. OA by AP corresponding OB by BQ. So you got one condition, okay. First condition we have used. Now second condition, what is the condition given? AC parallel PQ. So you see in the diagram second condition, which part we have to take out? AC parallel PR. Sorry, it is written wrong. It is PR. AC parallel PR. So again AC parallel PR. So which triangle again we are going to take? This triangle AOR. I am drawing it separately here again. It is like this. This is AOR and this is AC. We are taking out this part. Why? Because it is given AC parallel AR. So we can apply. You can mention here in triangle AOR. This is given here. Therefore, by BPT, basic proportional theorem again, AO by AO. This is P. This is not O. A P. So OA by AP. OA by AP. OA by AP equal to OC by CR by BPT. OC by CR. We will mark it equation 2. Now you see from equation 1 and 2, from equation 1 and 2, see LHS same for both. So if LHS are same, obviously RHS also must be same. So OB by BQ is equal to OC by CR. Now you see in triangle, in whole triangle you see triangle APQR. I am just drawing this. See, no, actually in triangle OQR only. This part, BC. What is given? You see, OB by BQ, OC by CR. In this triangle. Now in this triangle, it is already what we have got, OB by BQ, OC by CR. So in this triangle, BC must be parallel QR by converse of BPT. Therefore, by converse of BPT, what we can say? By converse of BPT, BC parallel QR. BC parallel QR. Converse of BPT is ratio equal then side parallel. Okay. So here ratio OB by OQ, OB by BQ equal to OC by CR. So BC parallel QR by converse of BPT, and this is the proof for this question. Okay. Question number 7. Same exercise continued 6.2. Question number 7. Using basic proportionality theorem, prove that a line drawn through the midpoint of one side of a triangle. We are talking about a triangle, so let us draw a triangle. A triangle ABC. So First you can just write like this: given in triangle ABC, what they said, the midpoint, a line drawn through the midpoint of one side. So D is midpoint of AB. In triangle ABC, what is D? D is midpoint of AB. D is midpoint of AB. And if we draw a line parallel to BC, DE parallel to BC, it is also given, drawn parallel to, and D is midpoint of AB. And to prove that E is also midpoint of AC, if D is midpoint of AB, to prove that E is also midpoint of AC, to prove E is midpoint of AC. That means you have to prove AE is equal to EC. Look, proof. See, since D is midpoint of AB, D is midpoint of AB. Midpoint means it is in the middle. So this distance must be equal. Therefore, AD equal to DB. We will mark it equation 1. Again, see, again what is given? It is said that DE parallel BC. DE parallel BC. Therefore, what we can say? By BPT, the ratio must be equal. AD by DB equal to AE by EC. Corresponding ratios must be equal of the other two sides. Like other two sides means AB and AC. So AD by DB, AD by DB, AE by EC. Now you see AE and EC are equal. Okay. Now since here AD and DB are equal from equation, so in place of AD is AD, in place of DB we can replace by AD again, is equal to AE by EC. AD by AD, so it is 1, cancelling, equal to AE by EC. So what we got, you see, EC is equal to AE. That means AE equal to EC. So we got AE and EC are equal. Therefore, E is midpoint of AD. That means E bisects AC. This implies point E bisects side AC. And this is the complete proof, you see. It was, I am explaining once again, it was given D is midpoint of AB, so AD equal to DB, and also it is given that DE is parallel to BC. So we have applied the basic potential theorem, and we have finally proved that E is the midpoint of AC. That means AE equal to EC. That means point E bisects side AC, and that is the complete proof for this question number 7. It is question number 7, okay, from exercise 6.2.